All right, hello everyone. Let's get these office hours started. People joining in, looks awesome. Glad to see so many people. Uh, we'll give it like one more minute. Just so everyone knows, we'll be here probably for like anywhere between half an hour to an hour, maybe a little bit longer if there's still good questions. So we'll do some talking here at the beginning. Have a couple of cool stuff to show you, and then we'll open the floor to questions and I guess basically talk as long as you want to listen. So looks like things we're filling up here. So I'll go ahead and get started here by sharing my screen. Good. All right. Um, Hey everyone, my name is Jeffrey Cannell, also known as Emozilla, CEO here at News Research, and want to talk to you guys about everything that's going on, particularly with Psyche and some of our other releases, give you a peek behind the curtain on some of the research stuff we're doing, and kind of talk about what to expect over the next few months. So, for those of you who don't know, I'm going to do just a super quick recap of what Psyche is. I'm not going to go over too many details, but for anyone who is maybe a little late to the party, Psyche is a decentralized training network, which we're currently using to train LLMs and also now multimodal models as well. And basically, the core innovation behind Psyche is that we're able to train the same model over data centers, GPUs that are not like together in the same location. Previously, people always have been doing training where they all have to be in one big data center, but because of this, because of some of the work we've done, particularly with the distro optimizer, we're able to train one big model all over the world using these GPUs and coordinate together. And to do this, we do it in a trustless way where we use the Solana blockchain to verify the state of the training so that there's not one centralized point of failure. And you really sort of have this entire worldwide mesh of computers training open source LLMs. This is like I said, this is a very high level overview of how it works. We have the Solana blockchain, which holds the coordinator state, the trainer clients, which then the trainer clients, which actually run on each of the nodes that have the GPUs. And then there's a communication mechanism where they all join up to a peer-to-peer network interface. They do back propagation to update the weights, and then they use the distro optimizer to send these. I guess you can basically call them compressed gradients, but compression is not technically the right word, but over to each other, and then the gradients are then re-expanded, decompressed, and the model updates. And this is the basic core loop of training every AI model that there is. It's just data forward, backward, update, and do that a couple 100,000 times, and you have a magical computer that can talk talk like a person. So Psyche does this on the Solana blockchain without any centralized components on GPUs that are all over the world. Um, and we've been scaling this out now, sort of on the Solana testnet at smaller sizes. But one of the things that we have done over the last month is really start the preparation of moving Psyche from being this testnet thing to something that's ready for production. And the way we decided to do that was to basically dog food this, ourselves and train the next iteration of our Hermes models using Psyche itself, right? So to be good, for everyone else in the world, it has to be good enough for us to use it as well. And so what we released yesterday was Hermes 4.3, which is the latest update to our Hermes series of models. And this was trained exclusively on Psyche. So it was trained on these GPUs that are all over the world. And this was kind of our final test that, like, yes, we can use this for the real thing. So while we did this, we understood that this is sort of a novel undertaking. And one of the things we wanted to prove both to ourselves and to the world, basically, was that this methodology will give you better, equal to, or better results than if you did it the centralized way. And so we took it upon ourselves to do an A/B test where we actually trained the entire model under the same regime that we trained the original Hermes 4 models are under. And if you go to the Hermes 4 technical report, we talk a lot about how we did the actual training schedule for Hermes 4, but ultimately it was done centralized using Atom W and fully sharded data parallelism. And so we trained Hermes 4.3 in the exact same way as we did with Hermes 4, and then we did the whole thing a second time on the Psyche network, and and that was sort of our test to verify that this all works. This was a little bit of a work because our trainers needed to be adapted for the new base model we use, which is the ByteDance Seed 36B, but it wasn't too bad. And what we ended up with was a baseline here. And in fact, I'll show you a little bit behind the curtain here. So this loss graph here, this is the actual. This is the Hermes WANDB for Hermes 4. So these are all of the Hermes 4 training runs here. And you can see, and what we have here, this is the actual the Hermes 4.3 36B trained using our modified Torch Titan fork, which I'll talk about earlier. And what was interesting was that you can see here, I'm going to turn on, this was the 70B we released a couple months ago. And you can see that the loss actually got to what we ended up observing, which is that this 36B is actually quite close to the original 70B that we trained. So the data updates that we made in 4.3 were quite efficient. Not quite up to. I'll turn on the all the big ones. Yeah, getting 405B was quite an adventure, but not quite to where 405B but certainly at a per parameter cost, the 36B is highly efficient. And so what we ended up with is a model trained on Psyche where the evals themselves are better than the centralized versions, right? And it wasn't unexpected for us because we'd observed this in the original distro paper and we reported on it, but it was sort of like it's a bold claim to make when when you're saying that my optimizer is better than state of the art stuff, and so we wanted to be careful about how much we emphasize that until we were able to validate it at larger scales. So we could see here that the Psyche 36B actually outperforms the 36B trained under Atom W on all of the downstream evals, and matches 70B. Or is quite near, like maybe a point or so off the 70B at essentially half the parameter size. And so the 70B, except for simple QA, which is a eval, which basically just measures how much a model has like memorized. So you always see these larger models do better because there's just more space in 70B to like memorize arbitrary facts. And so for this, we also made sure we did this with the previous ones. All of the evaluations that we did for all of these are actually completely open. Like you could even go in and look at like what did Hermes say for each of the evals across the entire sample set, all the MMLU, all of these, and get it here. So we put both the evals for this and the evals for the centralized and so this is the centralized evals here. You can compare and contrast exactly like all of the responses for full transparency about how we did it. And also we released the original centralized trained version, including like the Torch Titan config that we used to train it on Hugging Face as well. So sort of to put all the data out there in the effort of open science. And it's really a pretty nice model, and I would encourage you to use it in LM Studio. And so, sorry about that. My headset decided to turn off randomly. Okay, so the 36B is locally usable, and I would definitely encourage everyone to play around with it in LM Studio. Okay, so let's go on and talk a little bit now more about what's actually happening over on Psyche. So uh, this is the Psyche dashboard as it sits right now. Um, and you can see we've been running, we talked about this, I think we announced that we are going to be doing it last time, but we've been running a series of like high level data mixture experiments on Psyche right now for our own sort of internal use, and are training a whole bunch of, a slew of smaller models on several different data set mixtures to establish basically pre-training scaling baselines for everything. So each one of these are their own live run that's happening right now. What happened to my tabs? I guess streaming killed some of them. I don't know. Okay, let's see here. All right, well, here's one of them. So like here, for example, is our FineWebEDU DCM baseline stack EDU split. You can see the live evals that occur. This is something that's sort of interesting with Psyche 2 is we do in the loop evals on all of these, and so like at every step you can actually see what's happening here. HelloSwag is always a really good indicator for pre-training, as well as is Arc Challenge and OpenBook QA. So you can see the proverbial loss goes down, evals go up. Loop. And what's really cool is that so I'm coming back right here, like as we're talking, I can click right here, and this will actually take me over to the Solana blockchain where you can actually look at like all of the different things that are happening. You can see every transaction that was just a minute or so ago, and you can go back to this contract right here is the root Psyche coordinator, and if you look at it, you can see that there's like 50 or so transactions every minute going to this smart contract that's doing the training. So that's some of these mixtures we have here. We've got a FineWeb mixture going. We've got a DCLM-based mixture going. And these are all here. And in fact, you can actually even these buttons here, if you click on this takes you to just the page for a specific Psyche node. So you can see this specific Psyche node has its own basically like a wallet address where it sends all of its messages to the network. So we have all of these running, and I just to give everyone if people don't know, the optimization methods and the model architectures are really only like half the battle when it comes to making AI models. I mean, at the end of the day, the data is is ultimately the thing that matters. And so we've been benchmarking a series of these different open source pre-training mixtures and figuring out what's the right, how much code do you want, PDFs, all these different experiments that will fuel us towards being able to do giant open source fully open source foundation models. So we've been using, for example, the Nematron math data set, which is a very cool data set. If you ever want to go have time to read the paper, they actually did this really interesting thing where they go through the web using this thing called Lynx, which is like a text-only web browser to get the data converted and then deduplicate it all into a constant LaTeX format. They did a really cool job with that. FineWebEDU, which is from the Hugging Face team, which is a common crawl filter. As well as DCLM baseline, which is also a common crawl filter, but using a different style of filtering, which is actually based on the old Hermes data set. And so what's interesting is you could see, for example, like over here as we're comparing, this is like 100% FineWebEDU. At around step 200,000 here, we see the loss to like 2.4. Whereas over here, we're at like 2.68 on the DCLM one. So but if we look at the HelloSwag evaluations here, you can actually see that HelloSwag on the FineWebEDU is actually only up to like 58 at step 200, at 57% at 200,000 steps, whereas over here, we're all the way up to 61 using DCLM. This tells us, for example, something we already knew, but empirically verifying that the perplexity of the data that's in the DCLM data set is higher, and so it takes longer for the language to learn to model correctly, but it's in some ways maybe more verbose or creative, whereas like the DCLM, the Fine Web Edu data set is much more like bullet pointy list kind of stuff, which is easier for it to model, but perhaps on certain, isn't going to give you something like Helisag, which is measuring how well the model can finish arbitrary common human English sentences. So all these sorts of things give us insights into, we're using Psyche now to gain the insights into how all these different data sets mix together. And we'll talk more about where we'll take it from there. So data side is half of it, what we're currently running on the Psyche network. In addition, the Nous research team themselves have been committed to making the trainer that's in Psyche be, like as frontier as level as it can be, and even pushing the boundaries of what the frontier is. We use a heavily modified version of Torch Titan as the trainer, as our trainer internally, which we did for Hermes, all of our Hermes series. And this is fully open source, but it's got quite a, if you go check out the branch, it's quite extensive in its changes that we've made. But this is really trying to be working towards a full production scale frontier training training code base that is then linked into Psyche. So the Psyche code base will load this trainer in and use it to do the actual training. And then like the Psyche code base itself manages getting the data in, all of the checkpointing, the fault tolerance, the P2P connections, the Solana stuff, all of that's done in there. So this is some of the work that we're doing over here on the trainer side. You can check it out. And in particular, one thing that we've had a focus on recently has been getting training MOE models up to a point that is like at what the closed labs are able to do. So we've been doing a lot of ablations here. You can see this is the WangiB for one of our Mo experiments, and we've been running a series of of ablations to get the performance of the mixture of experts models training as performant as it can, including investigating different optimizers and a whole bunch of stuff I won't get into now because it's too in the weeds. But this is happening over here on this research branch, which is then going to be linked into Psyche, and this trainer will be the trainer that that Psyche uses. So that's what's happening on the training side, and you're probably wondering, how does this all actually fit together in the end. And so this is a very, very quick and dirty roadmap, I guess, of what's happening. So the black stuff here is kind of that's being done as part of Nous's research efforts, and the green parts are like the Psyche network as a larger thing, and how we're going to intertwine these things together and bring it to fruition. So I talked a bit over here about the moabulation research we're doing, especially things like NVFP4, ultra sparsity, new efficient attention mechanisms, which we gave a sneak peek of that at the PyTorch conference last month. Our chief scientist, Bowen, who is here up here with me as well, talked a bit, gave some hints as to where we're going with that. So on the Psyche network right now, where we stand is that we have queued up all of the breaking changes for the smart contract that we needed since we got it audited, and we're going to deploy those out and as sort of the RC candidate of the smart contract networks. And then after that, we are going to be releasing the run manager, which is the final package that the GPU providers can run on their system that manages self-updating. It loads the correct Docker environments. It's like this one executable that you can just run on your GPU, on your HGX or whatever, and start mining the Psyche network. And once we have this, we can then scale to larger to more and more GPUs on. And so the pre-training research that we have, which we talked about, the 3.6 baselines, we also have internally been doing lots of lots of mid-training research privately on obviously on synthetic code and math, but also for something that's important for us is the creativity preservation. I think I am not someone who loves GPT slop, and so we are trying to do everything we can do to keep the slopification of all this down. So that's what we're doing on the research side that we talked about, including giving like the final architecture finalization for Nous's foundation model training run that we're going to be doing on Psyche, and a couple of other things on the Psyche side also that are coming. Once we have this done, we're going to be doing a treasure dry run, which simulates all of the economic activity that will be happening on the network. We have the audits for that all back again on the updated one and good to go, as well as a new smart contract, which is our distributor contract, which we'll use to distribute all of the economic incentives to the users. And so once all of this gets sort of brought in together here, we then have everything merged into the one super psyche. And then really after that, it just becomes scale, 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 right? We can do more experiments and then scale up the actual final training runs to release foundation models that are fully open source, restriction free, that everyone can use that meet and eclipse what's happening at the closed frontier labs. And the only way we can do that is to scale, 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 scale. More GPUs, more data, and bring open source science the resources that it deserves. So that's sort of what's happening over the next few weeks, is getting all of these different streams that we've been working on over the past several months into the final merged product, and then up the scaling ladder we go. So that is kind of the quick rundown of everything we've been working on for Psyche and what our plan is over the next several weeks. I think now, I guess, Abed, you want to we can have Bowen come up, or how do you how do you want to do
Yeah,
this
yeah.
section?
I have some questions saved for Bowen for more so the research side that we wanted to ask, and
Hmm.
then after that we can do some general Q&A. And I have all the questions from the audience as well saved, and we'll run through those once we get past Bowen stuff.
Cool. So thanks, everyone. I'm going to pass it off to Bowen, News Researcher's chief scientist.
Thank you, Jeff. Yeah.
All right, Bowen, nice to have you. The first question we wanted to ask you is, what is the difference between distributed and decentralized training as it pertains to Psyche right now?
Yeah, so this is like kind of a point of confusion that a lot of people have because they sound really alike, right? So what I like to tell people, the difference between distributed and decentralized is distributed training, you focus on one model, many GPUs, right? So you have kind of this scheme where you want to train the final model, but the problem is it doesn't fit in one like mega GPU. That doesn't exist, right? NVIDIA makes like GPUs with a limited amount of VRAM because of like fabrication constraints, like also power constraints because you can't make an arbitrarily large GPU. So by doing this, you have to train a single model with all of these GPUs, like that could be in a data center or not even in the same data center, and that is called distributed training because you're trying to distribute the work, right? Like to other distribute it away from a centralized place. But decentralized training, it's not focusing on the GPUs, it's rather focusing on the contributors. So it focuses on one model, many contributors, right? So it's like it's not really the same as distributed because you could have one either distributed or decentralized and not both, right? So for example, if you only have distributed training and not decentralized, that means that you could have, let's say, OpenAI, like one lab or us, like control all the GPUs, and we are only one contributor and we have many GPUs which train one model, right? That is distributed training. And decentralized training, rather, that's one model, many contributors. So you could have one mega cluster, like in, let's say, in New York, right? And everyone's contributing to it by paying or like by paying some, that can be decentralized, but like not in the sense where you have one company controlling the model, you have many contributors, but it's still kind of like not distributed, right? So the GPUs are all in one place. So Psyche is a mix of a little bit of both, right? We want both decentralized scheme and also distributed training. We want to focus on both because you want a kind of a mix of, let's say we want to contribute a lot of GPUs, but some people want to contribute a little bit, right? Like it could be heterogeneous. So by having that, you would allow smaller players to contribute to the network by allowing distributed training and decentralized training. Many people right now are focusing on a single aspect, but we are trying really hard to unify both into Psyche, right? To have this like unified, both distributed and decentralized training platform.
Awesome. Yeah, that makes a lot of sense. The next question I had was, how does distro, like our optimization algorithm, scale versus other distributed training algorithms like DeLoco, for example?
Yeah, so distro came out not of like just randomness. It came out of necessity because what we're currently in is like we have a kind of problem where not really a problem, but our constraints is kind of we need to be optimized in the medium scale. What I'm saying the medium scale is not like the huge scale right now. Is we have a mixture of medium-sized accelerators and a mixture of medium-sized models. So if you want to train a medium-sized model using, let's say, 512 nodes or something like manageable, right? Like not like infinity, but just like that in that regime of training a 30B with 500 accelerators, we found out that distro scales the best in this case. So it performs much better in DeLoco because internally with DeLoco, we found that it was very, very good at like low amounts of accelerators training larger models. But it doesn't work in this case, like with Psyche specifically. So like internally, I don't know like if we done it correctly or not, but we could not use DeLoco for Psyche. So that is the like distro here is only born out of necessity. We are also still trying to unlock kind of the scaling to train much bigger models. So currently distro can hit a wall at like 1,000 accelerators, so independent nodes. If you go over that, it kind of like slows down the training because of the huge amount of data you still need to transmit. I think that's also a problem with a lot of other optimizers, not just for distro. But we're working really hard on unlocking the scaling. So hopefully one day we can train like a trillion parameter size model.
Gotcha. It sounds like a lot of those problems are kind of global issues with just the state of like the research around this subject right now. So that kind of leads into my next question. Is Psyche, would you say, the state of the art for distributed training right now? And if so, why? And then what are the remaining challenges on the optimization and the coordination side?
Yeah, thank you for that question. I would assume that Psyche is SOTA because we currently are the only framework that has proven to match centralized training given the latest release of Hermes, right? So this Hermes training run kind of proves that both we as a company or as a foundation know how to train these models and then apply it to Psyche, right? So we have the recipe to post-train Hermes, and that's working very well. And now we apply it to using a kind of a Psyche framework, and it just works. Like it works directly. So the previous training runs or the Conciliance, if you guys remember, that one like wasn't training as well as we wanted, so we like stopped it so we can focus on like more pressing issues. So right now we do believe that Psyche it is a SOTA because we're the only one kind of successfully trained a frontier model on this. We're still working on the pre-training, so we're learning a lot about it. And in order to prove that Psyche can also train these frontier model from scratch. So the goal is for us on the challenges of the optimization and coordination is really the scaling up and also making sure that we have internally like the best recipe to pre-train a model and to prove that Psyche does work on pre-training, right? We know it works, but it's pre-training a model is not just about Psyche, it's also about the model and the data itself. So that's why Jeff was talking about like half of the battle is the data, right? So we're working really hard on that. Yeah, hopefully we'll have our like Nous model from scratch very soon.
Sick. Thank you so much, Bowen.
Thank you.
For the rest of the time, we have some time for just some general Q&A. I have all the questions people put in the chat on my phone right now. I think I'm gonna go a little bit out of order here just because we were just talking about this. But one question we got from the audience was like, what kind of data do we wish we had that we don't have right now for pre-training and mid-training? And anybody at News can respond.
Yeah, I can jump in and talk on that one. I think, interestingly enough, for tech stuff, you can mostly approximate a frontier pre-training data set with open source data, pretty much. I'm not going to say you get all the way there, but it's pretty close. A mixture of the common crawl mechanisms that we have filtering along with what for example, what the Nemotron and synth and later like synth methods have shown with uh, rephrasing the source material. Like the recipe is pretty good on pre-training, except for a few areas, I would say. On the pre-training code section, actually, I've noticed recently that the still like the only kind of popular available code pre-training data set that's out there in the open source space is based on the Stack v2, which is now like a year and a half out of date. So a lot of the challenges with this is that not only do you need like the data, but you also need it like constantly updated, right? So like, a year and a half ago, that probably was near frontier level for, the code training, but now it's not because it hasn't been updated, right? And the libraries have all been updated and changed in the last year and a half and so on and so forth. So not only is it just the recipes for the data, but it's also like constantly doing it to keep it up to date with the latest the latest knowledge. So code, definitely the open source space is starting to fall a bit behind. And then I'll be frank with everyone here. Uh, yeah. The question in the open source space of how to handle copyrighted material is still, something that's out there, right? I think we all know that the closed labs take liberally from anything they can get their hands on. And in the open source space, we've sort of had to tiptoe around this and how we want to approach it. But if the goal was to have a full pre-training recipe, a full pre-training data mixture that was frontier equivalent, it's hard for me to see how you could get to that without using some of these larger, dubiously sourced data sets that are, full of copyrighted information. I think eventually, the courts, at least here in the United States, will eventually figure this all out. But it's sort of a gray area that everyone kind of acts like we're not noticing when we talk about pre-training data. So it's not so much on that one that we don't have the data, but it's like no one wants to be out there being like, oh, this is completely a full pre-training mixture because it needs some stuff that maybe no one wants to take public liability for. I mean, you could take a look example what happened to Eleuther AI with the pile, and that was like not even egregious compared to what is going on. And a lot of the people behind that open source movement, were like personally sued in different jurisdictions because of that. And it's just something that in the open source space, it's kind of like you don't want to be, putting a target on your back. So yeah, I'd say in that space for data, we have some work to do. Some of it's collection, some of it's keeping it up to date, and some of it is frankly has to do with like legal risk.
And what do the different data set mixtures on Psyche like teach you right now? What
Data set, yeah, it teaches me that one thing that we're learning right now is about, and then this is known in the industry, but we're working through re-verifying every every piece of it. Is how the curriculum transition works from mid-training to or from pre-training to mid-training. I had actually let me reshare my screen here. Here's I want to one of the data set mixtures actually we need to go back to it. So like this one right here was a mix of stack edu and some of the more advanced Nemotron math stuff within the actual within pre-training, and it actually performed very poorly. You could see it actually started to almost like diverge, and the evals started to like dip or go down. And we basically found that if you crank up, the complicated math and code too high into the initial pre-training mix, it actually actually hurts the model. So what is done nowadays is this mid-training thing where you like progressively do this quasi curriculum to introduce more and more complex data sources further along into the training. And we've empirically basically using Psyche and some of these other runs actually like verified this behavior.
Awesome. Yeah, I think that answered a few people's questions about that. Um, Changing to a slightly different topic, we had a question about synchronizing the weights among the nodes. Like,
Mm-hmm.
are you using Hugging Face as a medium, or like how does it
Oh
work
yeah,
exactly?
I could grab this one.
Sure.
So during training, given if everybody starts with the same initial model, and you've got a fixed set of nodes, the way that everybody synchronizes is by transmitting and receiving the same set of distro results. So when everyone does their step of training, they all communicate the results, this compressed thing, and we all apply it. Every single node will apply the same set of results, which gives you the same weight. So that's the synchronization step. Rather than like everyone copy and pasting the exact same weight, we just use the fact that if you apply the same changes to your pre-existing set of weights, you end up with the same weights. And then when you have a new node joining or you want to resume from a checkpoint or something like that, if you've got anyone on the network who currently has the set of weights, we use like a peer-to-peer weight sharing, where say, there's 10 nodes training this model, I join in and I want to start training as well. At the end of we call them epochs, at the end of like a round of training steps, my node will download the weights from all the other nodes currently on the network. So I'll just grab, parts from everywhere, whatever's fastest, to build the weights out so we can continue training. Then finally, if we're starting from a checkpoint, say, we want to pause a run, change some parameters, resume it, or maybe even start from like a different checkpoint, there we can use Hugging Face, where all the nodes will download, say, a single hosted copy of the weights and resume from there.
Yeah, so basically in the normal order of the normal ordering of things, the weights are kept in synchronization by the fact that if all the nodes apply the same distro result to the same weights, they'll all have the same results after it, and keep applying that principle of induction, and they all have the same one. And it's only when a new node joins, they download it directly over the P2P network, and only in like what we call a cold start case, where like there's no training run that has started at all, do we rely on Hugging Face. This right here is an actual, so this is like what we use Solana for, is each one of these, on the P2P network, everyone is sending their compressed distro updates to each other, right? And then they all send a witness to the Solana smart contract, which says, and you can just pull up one of these witness functions, that it actually says, okay, here's who sent me all of their updates. Here's who didn't send me their updates. Who's here who said that they were going to send me their updates, but they didn't. So all of those sorts of pieces get put, each node sends that information in what's known as a witness transaction. And then after the witness transaction, and hold on, I'll just find exactly the place it happens just so we can go to the source. This is the actual Solana smart contract that runs the coordinator. And there is a function in here which will get the where I just had it. Select consensus commitment by witness, right? So this actually on the Solana blockchain takes these transactions that we had, that each one of them put in, that said, here's who I got my piece of the distro result from. And then on here actually comes, this is the consensus mechanism that's actually pulling that's actually pulling it up. So hopefully, yeah, so that's what's actually happening, because if one of the nodes, for example, didn't sent their updates to some of the nodes but not the others, and what some of the nodes applied it while others didn't get it, then the weights would become decoupled and desynchronized, right? And so after everyone announces their broadcast, we have to come to a consensus about who actually sent it to everyone, who's going to get kicked off the run for not participating correctly, and that's all adjudicated within the smart contract.
Gotcha. Thanks, Jeff. We had another question earlier about the $500,000 mining pool that we had a few months ago, or it's been a while now actually. Maybe we could talk about kind of why we did that, and then yeah, if we're doing any more, or like what was the idea behind that?
Yeah, the idea was basically just to bootstrap the initial compute that we needed to do these runs in the testnet. So in testnet right now, there's no money moving around the system. So all these GPUs that you see that we're doing this for, we had to pay for basically out of pocket. So the initial mining pool was a way for people to contribute to the initial bootstrapping of the GPUs on the network. We are considering whether we want to open up a second one to bring us as we move to mainnet. I have no announcement or confirmation on that, but we are moving towards mainnet as fast as we can, and so we may or may not be opening a new one. But really, it was that initial 0 to 1 bootstrap, so that we could actually prove all this out before the economics kick in.
Gotcha. And then someone just asked, what is it that bound the pool capacity? And I believe they're talking about like the capacity of the compute, like for each like epoch, or like during training.
What bounded the compute capacity, as in what binds the maximum number of GPUs that we can put onto it?
Yeah. Like Technium was talking about how it's like demand and profitability over time.
Yeah. Okay, so this gets into the economic model of the of Psyche. So basically what happens is there's a forward declared amount of money that will an epoch will be paid out for completion of the epoch, which is defined as a fixed amount of time. And so like say 8 hours, right? And then what happens is we'll pay $10,000 or whatever, just picking a number for these 8 hours to be trained, right? Now, theoretically, if there was only one GPU that could come, we will actually pay the one GPU all that money, right? But if there's another GPU, it would make sense for them to also want to join that run, right? Because they're getting paid $5,000 an hour, right? And so basically what happens is there is a competitive market equilibrium where the per GPU payout will decrease relative to how many people join until it reaches like what is that the market equilibrium that both sides of the equation, the funding of the run and the people providing the GPUs, find to be the midpoint there. And so that's going to be what bounds the compute size on the network from an economic perspective. Because at some point, even if the run could go faster, no GPU will join because they'll get paid, next to nothing or something in like the terminal case, right? At which point, if we want the run to go faster, we need to allocate more resources to it, or let it be there. So it's driven at the top level by the economic model. On the technical side, Bowen talked a little bit about like once we get to like the thousands and thousands and thousands and thousands of nodes scenario on a single run, there's some technical networking stuff that we have to still get through to get to like the multi-thousands of Psyche nodes. And each Psyche node can be several dozen GPUs like that's sort of the number of GPUs to the number of Psyche nodes is not any cleared 1 to 1. It's like 8 right now, but can be larger. But in that scenario, if once we get to like multi-thousands of Psyche nodes, we have some networking work that we still need to do, but we'll be focusing on that post launch.
Gotcha. And then we had one more question. Someone asked kind of before this office hour started. about the licensing.
Mhm.
So the decision for the license was Apache 2.0, they said. And they asked if whether AGPL 3.0 is considered at some point to have rights to the source code of hostile nodes that may exploit issues in the contracting or something like that.
Yeah, I was
Yeah,
thinking
I'll
about
let,
this
yeah,
one.
go ahead. All right.
This is an interesting one because, it makes you it basically gives you a legal recourse if people participate in a way that goes contrary to the way you want them to. Um, while, it's definitely worth us like looking into it. All it means is that like if people misbehave on the network, you can stick your lawyers on them. And when you're talking stuff, like a distributed system in general, it might make sense. But when you're talking like something like an American business where you've got a bunch of legal parties participating. But when you're doing stuff that is designed to be eventually decentralized, it gets a little, less useful, one might say, because if someone's, putting the work in to attack your network and trying to extract economic value from it, you don't necessarily expect them to play by the rules and the law, anyways, right? So AGPL 3 is super cool. I'm a big fan of modifications being forced to be open source. The license we picked, I'm pretty sure we're happy with it for now, but we appreciate the suggestion. And we'll definitely like, think about it and think if it makes sense to like move contributors over to a license like that if we think it'll be beneficial for the project in the long term.
Yeah, and we spent some serious time actually with this license question. When we were comparing, do we just MIT it? Do we do Apache? Like, we spent some time with it. Forced open source contribution was an item we talked about, but ultimately we tried to make it just be clear that we are not trying to hold on. Pearl Clixis is something we control exclusively, and so we went with something that everyone knows.
Awesome. And then one more I had was could you talk a little bit about the Consilience run? And I was just curious if you were planning on resuming that run in the future, or doing like another version of it.
Yeah, basically what we came to realize is that we didn't have the pre-training recipe like fully correct, and it became difficult to compare whether things we were seeing in the Consilience run were expected or unexpected, which is why what we've put a focus on now has been to have full baselines for everything that we do, and only then do A/B testing against the psyche, any changes we do on the psyche side, right? And so a little bit had like the cart before the horse, sort of. Uh, on it before, and so we pivoted to getting baselines across the board, and then sort of an example of that, it would be like what we just did with Hermes 4.3. As far as whether we'll resume that, I think also in the time since then, as we really said, the pre-training, we need to have full competency on the entire pre-training stack. That's what we've been working on, just internally. And so we now have a much better idea of what that looks like. And I think if it is as we sort of alluded to in here a lot of times, we are going to be doing our own foundation model, start to end, from pre-training all the way through, online RL post-training, the whole kit and caboodle. But to do that, like I wouldn't use that shape of the model. I think Dent, unfortunately, like not unfortunately, what do you want to say? I was born in like the Llama days. I run Hermes 36B on my 5090. There's a soft spot in my heart for dense models. Getting to wrangle 405B was always like a great technical achievement in my AI career. And so. But the fact of the matter is that ultra sparse MOEs have proven to be the most efficient. And so, if we were to restart something, it would certainly be not only copying sort of like what is the accepted frontier state of the art, but then also including some research advancements that we've been working on internally. And so the answer is yes, we will be doing a pre-training, a full run. No, it won't be that model shape or size. But we will be using Psyche as the mechanism to scale so that we can do that, to do it again.
Awesome. I think we'll go ahead and start wrapping up the questions. We had one more thing that we wanted to kind of show y'all that we're pretty excited about. Hold on, let me invite Kanan to the stage real quick. I'm just going to share his screen. Okay, there we go. Yeah, so some of y'all in the community might have seen this, but we have a forum. I'll go and type the URL in the chat. It's just forum.newsresearch.com. As you're aware, we have like a Discord where we do a lot of like community stuff, have community discussion. But as we start doing more of these like really big training runs, we wanted to have a place for discussion that's, gonna exist, a year from now or 2 years from now, like something that people can look back to, right? I think discourse is great for conversation, but definitely if you want something that lasts, stuff could get swept away pretty easily. So we have this forum now. Kanan sharing his screen, and in this forum, you can see like you can talk in different channels about different topics. You can ask questions about Psyche, and I want to introduce this forum as a place where essentially, if you do have a question about like a training run or about Psyche, or something that you would like some sort of like if you wanted like a question answered from like a developer on Psyche, like Kanan and I are gonna do as good of a job as we can of like kind of getting you the answers that you need, right? Like I think we want to have a lot of information about Psyche crystallized somewhere, and really think this forum is the way to do it. We haven't talked about it a lot publicly yet. We're just kind of like teasing it here now for y'all. But go ahead onto the forum. It's live. You can go and create an account. You can ask questions in there, and we will do our best to get you relevant answers about like big training runs, like network operations and all that good stuff as we continue to grow the network. Psyche is, like one part of what we're doing. It's our backpropagation network. We're excited to be doing a lot of like pre-training and post-training on there. But we really like to scale up our operations in the future to, like a lot of different activities. And we really think of the forum could be a great place to kind of see that network grow, right? Like if there was a documentary, on News like 3 years from now, I'd really think it'd be great if there was some cool forum post they could look back to on like the origins of how we did the cool stuff that we're doing. So yeah, thanks Ken for showing that. And yeah, it's live. Anybody can go and create an account. And yeah, we will do our best to get your questions answered on there. All right, I think that is it from me. We can go ahead and wrap up office hours. I want to definitely shout out the entire Psyche team. It's a huge undertaking. A lot of people worked on this in different ways. So congratulations for kind of getting this far. Also 4.3 or Hermes 4.3 release just came out recently, so that was really cool. Jeff or Bowen, or anything else you wanted to say?
Nope, other than let's go build open source AI that works for everyone, not for the few. Let's do it.
Let's do it.
Yeah.
See ya.
All right, thank you so much. Bye.